My dear students, in my previous video, I started the 10th chapter, straight lines, in your CBSE syllabus, mathematics, plus 1 mathematics, 11th standard mathematics, I mean. The 10th chapter, straight line, I have started in the previous video, and I gave some important formulae, some 8 formulae I have given you in my previous video. In this video also, I am going to continue some important results which we are used to solve the problems in the exercise and in the chapter straight lines. Chapter 10, straight lines. Important formulae. In that, some 8 results I have given you in my previous video. The 9th result is slope of a straight line. Slope of a straight line. Slope of a straight line means the angle made by the straight line in the positive direction of the x-axis. See. This is x-axis and this is y-axis. This is a straight line and it makes an angle theta with the positive direction of x-axis. And the slope of this line is tan value of the angle made by the straight line with the positive direction of the x-axis. That is tan theta. So slope of a straight line means the angle made by the straight line in the positive direction of the x-axis. Its tan value, tangent value is called the slope or gradient. Slope of a straight line is always called gradient. Both are same. So, the angle made by the straight line in the positive direction of x-axis is slope of the straight line. It is denoted by m and it is the value of tan value of the angle theta, tan theta. Slope of the line is tan theta. It is denoted by the symbol m. And this angle is 180 minus theta. So negative direction. The line makes an angle in the negative direction of x-axis is 180 minus theta. The total is 180 and this is 180 minus theta. And the line makes an angle in the positive direction is theta. And its tan value is the slope of the straight line. Now, again, slope of the x-axis. Now I am going to explain slope of the x-axis. What is the slope of the x-axis? What is the angle made by the x-axis with the x-axis in the positive direction? In this case, theta is 0. 0 degree. Angle made by the x-axis with the x-axis is 0 degree. Therefore, the slope of x-axis is tan 0, that is equal to 0. So, slope of x-axis is 0. And similarly, slope of the y-axis. Slope of y-axis. Y-axis makes an angle 90 degree with the positive direction of x-axis. Therefore, theta is 90 degree. The tan value of this is slope. That is tan 90. Tan 90 is infinity. That is not defined. So slope of y-axis is not defined. Slope of x-axis is 0. These are the 2 things you have to remember. Slope of any line is the angle made by the tan value of the angle made by the line with the positive direction of the x-axis. And slope of x-axis is tan 0, 0. Slope of y-axis is tan 90, which is not defined. Next, I am going to find out the slope of a line joining 2 points, 2 given points. That's our next result. Next, slope of the line joining two given points. 12th one. Slope of a line joining two given points. Slope of a line joining two given points, say P x1 y1 and Q x2 y2. You consider the same line. It is the point P x1 y1 and it is the point Q x2 y2. So this is the slope of, we have to find out the line PQ joining by these 2 points P and Q in terms of the point given. The line making an angle theta with the positive direction of x-axis, and I draw an ordinate at the point x1 because this is x1, this is x1 origin, this is x1 and this is x1 distance and this is y1. Similarly, you have to draw another ordinate from the point Q at the point x2 and this is y2. The length, this is the total distance is x2 and the distance is y2. Q O x2 and this is y2, and join the line. These two lines, it meets at the point M. The right angle triangle at the point M. And these two lines are parallel, x-axis and BM is parallel, therefore this angle is same as theta. This is theta and this is also theta because they are same angle. These two PM and YX are parallel. These two lines YX and PM are parallel, therefore this P angle QPM and POP, say for example OQ, OX, that means that this is theta and this angle is also theta because two parallel lines, and PQ is a transversal. These two angles are same angles, therefore they are equal. Now I am going to find out the slope of this line PQ. The line PQ is, slope means slope of the line joining the 2 points is slope M, which is equal to tan theta. So this is equal to tan theta is the triangle PMQ. It's a right angle triangle. Tan theta is opposite by adjacent. Tan theta is opposite by adjacent. That is QM by PM. Opposite. QM by PM. This is the tan value of that angle theta. Tan theta is opposite by adjacent. Opposite is QM. Adjacent is PM. And also you know QM. QM is distance. The full length is Y2 and this is Y1. Therefore, this length is y2 minus y1. The full length is y2. You subtract y1, you will get y2 minus y1. QM is y2 minus y1 by PM. PM, full length ym is x2 and minus yx1. That means x1. x2 minus x1. This is PM. x2 minus x1. Total length x2 minus x1, you subtract PM, you will get PM x2 minus x1. Therefore, the slope of the line joining P x1 and Q x2 y2 is tan theta. Slope is y2 minus y1 by x2 minus x1. This is the slope of a line joining 2 points x1 and x2 y2. Suppose this is another result. Slope of a line joining 2 points is y2 minus y1 by x2 minus x1. How I get this result is from the right angle triangle PQM opposite by adjacent QM by PM. QM is y2 minus y1 and PM is x2 minus x1. Therefore I get this. Now for another from this side result, What is the slope of two parallel lines? If the two lines are parallel, what are the slope of these two parallel lines? If the two lines are parallel, then their slopes are equal. Then the slopes are equal. How I can say? I will erase this diagram. I am going to erase this diagram. Slope of these two lines, if the two lines are parallel, what are the nature of the slope of these two parallel lines? These are the two lines. This is theta 1, the line L1, and this is theta 2, line L2. L1 is a line, makes an angle theta 1 in the positive direction of x-axis, and L2 is a line, makes an angle theta 2 with a positive direction of x-axis. Since the two lines L1 and L2 are parallel, these two theta 1 angle and theta 2 are equal, because here also L1 and L2 are parallel. OX is a transversal. OX is a transversal, therefore theta 1 and theta 2 are same angles. By the parallel lines condition, these two angles are equal. Therefore, L1 and L2. L1 is a line making an angle theta 1 with the positive direction of x-axis. L2 is a line making an angle theta 2 in the positive direction of x-axis. Since the two lines are parallel, OX is a transversal, theta 1 and theta 2 are same angles, they are equal. Therefore, if the two lines are parallel, angle theta 1 equal to theta 2. Therefore, tan theta 1 equal to tan theta 2. Therefore, the slopes are equal. Tan theta 1 I can say M1. Second line slope of the second line is M2. So M1 equal to M2. Slopes are equal. Next condition, if the two lines are perpendicular, what are the nature of the slopes we will see. If the slopes are, if the two lines are parallel, their slopes are equal. Next. Next one. If the two lines are perpendicular, what is the nature of their slopes? If the two lines L1 and L2 are parallel, in this case L1 and L2 are perpendicular. For this, so L1 is a line making an angle theta 1 in the positive direction of x-axis, and L2, this is L2, it makes an angle 90 degree with the line L1. So L1 and L2 are perpendicular. In this case, I will draw the line here. These two lines are perpendicular. L2 is here. I am going to draw the line L2, because the angle made by the line L2 in the positive direction I want. Therefore, I can draw the line L2 here. This is the line L1 makes an angle theta 1 in the positive direction of x-axis, and L2 is the line perpendicular to L1, and the line L2 makes an angle theta 2. Theta 2 in the positive direction of x-axis. So slope of the line L1 is, slope of the line L1 is M1, that is tan theta 1. Theta 2 is the angle made by the line L2, which is perpendicular to L1. L2 is perpendicular to L1. Therefore, theta 2 L2 is perpendicular to L1. and theta 2 equal to, theta 2 is the angle made by the line L2 with the positive direction of x-axis. Theta 2 is, this is also 90 degree. In a triangle, the exterior angle is equal to sum of the two interior angles. By a triangle law, angle between the triangles, if the exterior angle of a triangle is equal to sum of the two interior angles to the opposite side. The angle opposite to sum of the two interior angles. Theta 2 is the sum of the two opposite interior angles. Therefore, theta 2 equal to, this is 90 plus theta 1. This is 90 plus theta 1. Sum of the two interior angles is equal to theta 2. Therefore, tan theta 2 equal to tan 90 plus theta 1. Tan 90 plus, what is that? 90 plus is second quadrant. Second quadrant is tan negative. 90 changes the tan value into cot, tan into cot. Ratio is changed since 90 is not multiple. Therefore, tan 90 plus by trigonometry is minus cot theta 1. So, tan theta 2 is, I can call it by M2. M2 equal to minus 1 by cot theta 1 is, I can write it as 1 by tan theta 1. Cot theta 1 I can write it by 1 by tan theta 1, minus sign is because why I get minus here, tan 90 plus the second quadrant tan negative, and odd multiple 90 changes tan into cot, so minus cot theta 1. I can write it as minus cot theta 1 by minus 1 by tan theta 1, that is minus 1 by tan theta 1, you know M1. So this is M2 product, M1 into M2 equal to minus 1. This is a condition for the two lines are perpendicular. Condition of perpendicularity of two lines. If the slopes of the perpendicular lines, their product of the slopes is minus 1. If the two lines are perpendicular, then their product of the slopes is minus 1. Okay? These are the another two conditions for perpendicularity and parallelism. And I will stop here. In the next video, I will continue the remaining result and the exercise also. Thank you.